Hey everybody, Mr. Judson here. So we have one more day of working with linear equations, and what we want to do today is we want to kind of push this into problem solving. Story problems, our favorite, right? Right up there with fractions. That's not bad, it's not bad. The thing we have to remember is with story problems that involve linear equations, they're going to ask us to write the equation of a line or find the slope. It's all the same stuff as before. They're just giving us the information in a different way. Okay? So let's read this one. It says here that the average salary, or we're talking about average salary. It says the graph shows the average salaries for senior high school principals from 1990 to 2002. So I guess we're talking about what Miss Ray would make at her job. I suppose this could include vice principals as well. So part A, it says to use the slopes to determine the time periods in which the average salary increased the greatest and the least. Now I could look at this and say I think that's the smallest slope and I think that's the biggest slope. So that's where it increased the greatest, that's where it increased the least. But that's not really what they're asking us to do. They want us to look at the slope and make sure. So really they're asking us to find 1, 2, 3, 4, 5, 6 different slopes in part A. So if I did that, so I'm just going to label these first, second, third, fourth, fifth, and sixth. And so I'm going to say that slope 1, I'll take these 2 points right here and I'll do y2 minus y1 over x2 minus x1. And then I'll do the same thing with the next 2 points and the next 2 and the next 2. So I'm going to go ahead and shut the camera off while I do this so that you guys don't have to sit here and watch me calculate a whole bunch of slopes. Alright, so I'm having a really bad technology day. I just realized I was sitting here recording about 30 minutes worth of video and my camera wasn't even working. So I got to go back and do it all over again. So anyway, I had labeled these segments 1 through 6, and here's the slopes. I went and calculated the first slope, the way I should, but then I realized I'm just subtracting these 2 numbers and then dividing by 2. Because when I do my x2 minus x1, the difference is always 2 years. That's what we have here is 2-year gaps. So I just subtracted them on the calculator and divided by 2, and here's all the slopes that I got. So the first question says, use the slopes to determine the time periods in which the average salary was or increased the greatest and the least. So all I got to do is look at these numbers and say, there's the largest one right there. So this is our greatest increase right there. And then the least, here's the smallest one. So when you look at that, remember slope is a rate of change. It tells us how things are changing over time. And what we're talking about is the principal's salary per year. So these first 2 years, this is kind of nice. It means that their salary increased by over $3,000 per year. I'm not sure what happened in this time period, but not so good. Their salary still went up. I mean, I guess that's good, but only by a little over $1,600. And it looks like, most of these are in the 2,000 range. So, I look at that and it says to me that if you're a high school principal, you can just count on your salary increasing by over $2,000 every year. Next year I would make, $2,000 more than what I made this year. Okay, or over $2,000. All right, so there's the first question. The second one, it says, find the slope of a line segment connecting the years 1990 to 2002. So 1990 is this point right here. 2002 is this point right here. So what we're looking for is an average salary. How did the principal's salary increase over that 12-year period? So I'll do part B right here. My slope is going to be y2 minus y1. So I'm just going to do this on the calculator. 83,944 minus this y value, 55,722. Okay, I'm just doing y2 minus y1. And I got 28,222 divided by x2 minus x1, so 12 minus 0, that's 12. And so now if I divide that, I get 2351.83. All right, so we've got one last question here that we have to answer, and that is they want us to interpret the meaning of the slope in part B in the context of the problem. And so anytime you're ever asked to interpret a slope, I've got this nice, easy phrase that if you just get in the habit of using this, because it'll always work, and it'll work all the way through calculus next year as well. And the phrase is this. This is for part C. Something, we'll write something in there in a second, is increasing or decreasing. We're going to have to make a choice between one of those words. And it really depends on, is this slope positive or negative? So since that's a positive slope, we're going to choose the word increasing for this one. But if it would have been negative, I'll choose decreasing. So something is increasing or decreasing by a certain amount for each of something else. So when they say in the context of the problem, what it means is what's your y value referring to? And over here, this is your slope. What is the slope? And this is your x value. What is it referring to? So if I go back up to this graph, the y value refers to the principal's salary. So the principal's salary is increasing, because it's positive, increasing by $2,351.83. So this number right here is just going to get written into that spot, whatever the slope is, for each whatever x represents. Well, let's see, x is the time in years. So if I'm going to interpret this slope, what I should say is the principal's salary is increasing by $2,351.83 for each year. That's my interpretation. Okay? I'm not going to finish writing this out. I'll let you guys fill in the blanks. But this phrase is the one you want to use every single time we ask the question, what does a slope mean? Or to interpret what the slope means. All right, let's try another problem. All right, so I know this is a little blurry, but we'll do the best we can. I'm just doing a cut and paste out of our textbook. So what this problem says is that the cash flow per share, so we're talking about shares of stock, for the Timberland Company was 18 cents in 1995 and $4.04 in 2003. Write a linear equation that gives the cash flow per share in terms of the year, and they want us to let t equals 5 represent the year 1995. So again, that means 0 is 1990. Then predict the cash flow for the years 2008 and 2010. All right, so in order to do what they're asking for here, it says right here, write a linear equation. Y equals mx plus b. I need that. But I can't do it until I get 2 points. And so I need to get 1 point from this information right here and 1 point from this information right here. And again, the whole concept of, well, which one's the x value and which one's the y value? X always equals time. Always, always, always. Okay? The only person that will tell you anything different is Mr. Richardson, because in chemistry, I guess you do some experiments where you want to know how much time it takes per whatever the reaction is that's happening. But anywhere else in this world, you're going to always let x equal time. Always. Okay? So that's year 5. So one of my points is going to be 5, 0.18. And this would be 13 years later, after 1990. So 13, 4.04. Now, and again, you look at that and you go, oh man, decimals. Well, that's life. I mean, those are numbers that we have to deal with. And we need to get to a point where that just doesn't really bother us. Okay? So I need a slope. So slope equals y2 minus y1 over x2 minus x1. I'm just going to do 13 minus 5 in my head and get 8. And so now I need to go ahead and subtract that. So 4.04 minus 0.18. I get 3.86, and I'm going to divide that by 8, which gives me 0.4825. There's my slope. Now, I know I said that we're going to round to 3 digits, but really that's just the final answer. So I may go ahead and just keep track of all 4 digits past the decimal until I get there. Okay? So now I want to write the equation of my line. I'll just go with this point. Y minus the y value equals the slope, which is 0.4825 times x minus the x value. And so first step is to distribute this. So I'm going to go ahead and do that. I've got y minus 0.18 equals 0.4825x minus, I just need to take 5 times this. I still have it in the calculator, so I'll just hit times 5. And I got 2.4125. All right, so my last step is I have to move this over here and add that to the other side. So y equals 0.4825x. I'm going to take this number and I'm going to add 0.18. And so what I have now is minus 2.2325. All right, there's my equation. So now I just need to plug in my numbers. So y at 18. So remember, they asked us to predict what the cash flows were for the year 2008 and 2010. So if 5 is 1995, that means 0 is 1990, and so this year would be 18 years later. This would be 20 years after 1990. So I'm going to plug in an 18 first and then a 20. I just want to put 18 right there. So I'm going to go 0.4825 times 18 minus 2.2325. And what I got was 6.4525. And then if I plug in a 20, so I'll go back and put a 20 where I had the 18. And this time I got 7.4175. Which really what that means is this stock is now worth $6.45 per share. I shouldn't say now, 2008. And in 2020, this stock is worth $7.42. This is interesting. So if I want to know what it's worth in the year 2020, that means I should plug in 30. And if I do this same thing, I now get 12.24. So I don't know if you guys understand stock very well, but it's when you buy stock, what you're doing is you're giving your money to a company, basically loaning it to them, so that they can conduct business and do things, and the business becomes profitable, and then they have to share that profit with you. You're a shareholder, and so you get some of that money back. So let's just say that I had $10,000 that I want to invest. This has nothing to do with our homework, okay? This is just a little side note. And originally, this stock cost 18 cents a share. So I divide this by 0.18. So let me do that on my calculator. 10,000 divided by 0.18, and I would have been able to purchase 55,555.6 shares of stock. And today, that stock is worth $12.24. So I need to take my shares, the number I have, times this price, so times 12.24, and my stock is now worth $680,000. Oh. I invested $10,000, and 30 years later, it's worth $680,000. That's amazing. That's why you hear things like the rich people get richer. Because they take their money, their extra money, and they go buy a cheap stock like this and keep it for a long time, watch it grow, and one day they just walk in and go, I want to sell it. Can you imagine this company, all of a sudden they got to fork out $680,000? The stock's going to go down today when that happens. Because all of a sudden they don't have as much cash available as they used to. But that's how trading stocks works. A lot of people study the stock market in college, and then they have a job where that's all they do is manage stocks and make money. Kind of an interesting way to make a living. All right, let's try another problem. All right, so we've got another problem here. It says, and I'm just taking these out of our book. A school district purchases a high-volume printer, copier, scanner for $25,000. And after 10 years, the equipment will have to be replaced. Its value at that time is expected to be $2,000. And they want us to write a linear equation giving the value V of the equipment during the 10 years it will be used. So you guys go ahead and try this. Remember, you want 2 data points. Once you have 2 points, it should be easy to write the equation of a line, and that's what they're asking us to do here. Okay? Go ahead and give it a shot. All right, so my 2 data points. I know x always equals time. So what I'm going to say is, in the beginning, which would be year 0, this was worth $25,000. At that point right there, I already know my y-intercept, right? Because that point is on the y-axis. So that just made my job a little bit easier on this problem. My second data point is after 10 years, the equipment will be worth $20,000 or $2,000. So 10 comma $2,000. Wow, copy machines are not a good investment. All right, so I want to find the slope. So I'm going to do, let's do y2 minus y1. So 2,000 minus 25,000 over x2 minus x1. And so when I get there, I'm just going to do this whole thing on the calculator in one shot. So 2,000 minus 25,000 equals, and divide that by 10. So I got a negative 2,300. Now again, it's always good to stop and just think to yourself, what does that really mean? What did I just find? Remember that interpretation that we just did on a previous problem? It means the price of this copier is decreasing by $2,300 per year in value. Not a good investment, right? I mean, it's a necessity. You need that to do business, but it's worth less than it was when you bought it. It's like a car. It's not a good investment. It depreciates immediately. All right, so if I know my slope and my y-intercept, I can just go straight to the equation. I'll use v for value instead of y, equals a negative, so I'm thinking this way. I'm thinking to myself, y equals mx plus b, okay? I'm just going to use v instead of y. My slope is a negative 2,300 times x or t for time in years plus 25,000. So I have this equation in y equals mx plus b form, but I'll tell you what, the people in Europe would look at this and go, You Americans are weird. And they're right. They would have written the equation this way. The value is, it starts at $25,000 and then it decreases by $2,300 per year. And if I had to try and argue that our method is better, I would look a little foolish. I think their method is a little bit better. So really, either one of these, I mean, it's the same equation, but either one of those is a good way to write that. And so, write a linear equation given the value V of the equipment during the 10 years it will be used. So at that point, we're done. There's nothing else to do. Right? If this kept on decreasing in value, would it eventually be worth a negative amount of money? That's an interesting question. I suppose we could say the answer is yes, in the sense that I might have to pay somebody to come and take it away. I can't just sell it, I got to pay to get rid of it. There are some things in life that are like that. You'd like to be able to turn around and sell them, but no, nobody wants it. So you got to pay to have money come and take it away, or have someone come and take it away. I don't think it's really going to continue to go negative. It's not going to cost more as time goes on, but yeah, it could have a negative value. All right, let's try one more problem. A pharmaceutical salesperson receives a monthly salary of $2,500 plus a commission of 7% of sales. And they want for us to write a linear equation for the salesperson's monthly wage, W, in terms of their monthly sales, S. Okay? So, again, I'm going to think, okay, linear equation, y equals mx plus b, but they want me to use W and S. Okay? So my wage is going to equal what? You guys go ahead and write it down real quick. So this, if this seems really easy, it is. I'm going to take that European approach. My wage is, I start with $2,500 every month, plus I get 7% of, that word of means to multiply. So 0.7 times whatever I sell, which they want us to use sales S. I can't stand the variable S because a lot of times it looks like a 5, right? So write a linear equation. W equals 2,500 plus 0.7 S, or if you want to write it this way in y equals mx plus b form, you could say 0.7 S plus 2,500. There it is. We wrote the equation, and so we're done. All right, here's your guys' assignment. All right, so we're starting our third week, so this is assignment number 3, and we're going to do page 36 to 38. We'll do number 98, 101 to 104, 106, 109, 112, and 117. That's what we have for tonight. All right, I know I keep on saying to you guys I'm going to try and get 3 days going a week here. I think that's probably not going to happen this week. Remember, I'm going in for surgery on Friday this week, so I'm going to spend this Wednesday trying to get things ready for the day that I'm in surgery, but also for the first couple days next week. So it may not be until 2 weeks from now that we start hitting 3 days a week. Okay? We're going to have to do that, though. We have no choice. We can't do 2 days a week and call that a normal school year, where normally we'd be here 5 days a week. So 2 weeks from now, we'll start seeing 3 videos per week. All right, that's it. You guys have a good day. I will see you on, I guess it's Thursday or Friday later. I don't know when I'll see you. I can't keep track of this. All right, take care.